Boom, there's a record button too. So Ayana, it might have been you or someone asked about how can I find out architects that do LEED work. So I gave you a couple links here on the usgbc.org website for either organizations or people where you could potentially, I didn't look at either of these too carefully, but theoretically you could search for architecture firms. This is probably a better one. Again, the same website, they have both a list of projects and you can filter, you can export to Excel. If you're like me, I'm an Excel geek, so I always do stuff in Excel and filter it. You have a search function. You can download a copy of the scorecard. For instance, this is where I had found a copy of the scorecard for the Triton H building. In another week or two, I'm going to give you an assignment to go find a LEED certified building and go look at it and see if you can, download the scorecard and figure out what makes that building LEED certified. This is where you would, find a list of projects. Someone asked about credential maintenance, right? Like any professional credential nowadays, you typically have continuing education requirements, right? Me, I have a professional engineer's license in the state of Illinois, so every 2 years when I renew my license, I have to certify that I've done 30 hours of continuing education. So the same is true for LEED GA here. So, if you get the LEED GA credential, as I hope many of you will, take this class, do some studying, sit for the exam, pass the exam, then you'll have to keep your credentials up to date. You'll have to do 15 hours of CE or continuing education every year. Right, so in my case, there's always, various webinars through my professional organization. There's webinars through the Illinois Green Building folks. I'll send a link out for that. Right, so again, like any certification, the certification folks are expecting you to continue to learn, to not get stale, right? To continue learning stuff. And same thing if you're a LEED AP, you have the same requirements except for the fact that you have a 30-hour continuing education every 2 years rather than 15. And again, I'll post this on Blackboard. I'll post it as a PDF so you can grab these links. But there was a quick little YouTube about credential maintenance and what that means. Again, this is typical for almost any professional credential that you're gonna undertake these days. LEED AP, or in my case, professional engineer. Does that make sense? Okay. We talked last week about, or probably last 2 weeks, about stormwater and rainwater. And the purpose of that discussion was to give you some background information that ties into the LEED credit area for sustainable sites. So just like we did before with LT, or location and transportation, right? I'm providing some background knowledge, and then we'll see how that applies to specific credits for the LEED, in this case, a LEED SS, or sustainable sites credit category. It's making me crazy here. The little green light on my computer is blinking on and off, so I'll try to ignore it. Anyways, remember, just like in real estate, Ayana, right? Location, location, location are the three most important things. The same is true for green buildings or sustainability, right? Location is an extremely important aspect of sustainable design. Where the project is located and how it is developed has multiple impacts over the life of the building. So in the case of LEED NC for new construction, where you locate is extremely important. Obviously less so if you're talking about operation and maintenance. The building is already there. You're not going to pick the building up and move it, right? Ideally, we want to, if we have a choice, ideally we want to redevelop in an existing site or an existing building, right? Renovate an existing building, which we call adaptive reuse. Do an infill development, develop sites between existing structures, remediate, if possible, a brownfield, right? A gray field and brownfield are definitions for previous developed sites. Brownfield typically means that that site has some contamination from a previous use. Sometimes brownfield sites can be challenging, right? A corner lot that was a gas station at one point, right? That might be a brownfield site. Yes, Berry Park was a brownfield. Good question, Ayana. I live near Berry Park. I don't know if you were here. Oh God, this is going back 15 or 20 years ago. Berry Park is in Southeast Oak Park, where I live. It's currently a park district of Oak Park. But at one point it had a manufactured gas plant, right, in the early part of the 20th, late 19th, and I think early 20th century. There was a plant where some company turned coal into what's called manufactured gas, or town gas, right? This is an early form of, before we had natural gas. So when that industrial site was done, the buildings were demolished, and a park was put on top of that site, and then eventually somebody realized there was some coal tar contamination in that site. So in the case of Berry Park, the park was closed down, and there was a multi-year remediation done of that site. I remember it because it was a time my son was probably in middle school, right? The time that I would have expected him to grab his buddies and go a couple blocks away to the park and have a pickup baseball game or something like that, right? But in this case, he couldn't do it because the park had a fence around it and a structure covering the site where they were doing remediation. So again, brownfield sites have challenges. It doesn't mean that we shouldn't try to remediate them. It just means that it's a challenge, right? We obviously want to locate it near existing infrastructure. That allows us to reduce costs for utilities, avoids sprawl, to consolidate development, make it more compact. A couple of weeks ago, we talked about density, how density was desirable and sprawl was undesirable. So again, building on a previously developed site avoids some of that. The flip side of that, we obviously want to protect habitat. Want to, if possible, avoid greenfield development. Greenfield is an undeveloped site, right? I put greenfield in red there, right? That would be something we would try to avoid if possible, right? In many cases, greenfield development is a lot easier, right? You can have larger parcels of land. There's no existing structures to contend with. There's no, potential remediation of a brownfield. But unfortunately, then you're taking agricultural land or grassland or forests or something like that and turning it into something else. So again, that's in the LEED rating system. We are trying to discourage that, and for many reasons, we want to consolidate development and try to build density. If possible, again, site design strategies. I have my little LEED toolbox here, things that you as a designer or an architect or developer, whatever your role is as a construction professional, things you want to keep in mind. Right? If we are developing in a greenfield site or an open site, ideally we want to try to reduce the footprint of the building, reduce the amount of land that we are impacting, preserve open space in our development, try to stay away from what I call sensitive areas here, right? Sensitive area, let me put the pointer on, right? Sensitive areas might be bodies of water, wetlands, wildlife habitat, right? Ideally, we want to try to avoid those sorts of things. Here's a term, FAR. FAR stands for floor area ratio. We'll see what that looks like on the next slide. Right, again, maybe we want to look for ways of decreasing the amount of land and increasing, stacking up the building at multiple stories. Again, we reduce impacts by minimizing hardscape. Again, hardscape is places where the water doesn't soak into, parking lots, tennis courts, stuff like that, right? We want to try to minimize hardscape, reduce surface parking. LEED uses the term tuck under, right? Tuck under or under building parking, right, would be to have the parking garage, if parking is required, under the building. So reducing the amount of hardscape. It would be nice if we didn't have to do parking, but parking requirements are sometimes a requirement of zoning, right? The zoning may say if you're doing a commercial development and you have to have X number of parking spaces, right? That would be something we would want to avoid. We talked a couple of weeks ago about transit-oriented development. Transit-oriented development quite often means that we are trying to minimize the amount of parking that is built with our building. Again, we want to be able to use, if we are going to do landscaping, ideally we can use native or adaptive vegetation. right? Plant species that are adapted to the particular climate, right? Just like our rain garden by the H building, right? Those plant species in the rain gardens are ones that, you know, are adapted to the summers in this climate. You know, reduces the need for irrigation and landscape maintenance, you know, as opposed to, you know, lawn or turf grass, right? Turf grass requires irrigation, requires lawn mowing, et cetera, right? Turf grass is kind of a high maintenance landscape. Right, floor area ratio, again, this would be regulated by zoning, right? We talked about zoning a couple of weeks ago. Zoning is the rules of development for that municipality. So again, if we stack up the building in multiple stories, we're increasing the floor area ratio, you know, basically putting more building on a given lot area. So increasing the FAR, or the floor area ratio, would mean we'd get more building with less land area, less site disturbance that may or may not be allowed by zoning. Right, site design strategies, again, I'm going through things that are in the LEED SS, or Sustainable Sites credit category. Right, we want to prevent light pollution. Light pollution is in this Sustainable Sites category. You know, we want to the extent that we can, protect and restore habitat, set aside protected areas on the site, you know, have a management plan. Sorry, my video is probably still cutting in and out here. I don't know why that is. I don't want to have to break down and buy a new computer, right? Computers are expensive. If you remember way back our first or second, I think second class, we went to Cernan and we saw that presentation on losing the dark, right? The idea of light pollution is tied into the LEED Sustainable Sites category. And I can't remember now, hopefully we pointed these out when we were walking around, but you know, dark sky compliant light fixtures means that we're directing that light downward, less glare upward, less energy used for the same amount of illumination, right? So this is again, this is a design strategy that has multiple benefits, you know, less light pollution, less energy use. And if we do our job as designers and construction professionals well, we're still providing a safe site, right? Because people are concerned about site safety, right? We still have to maintain safety. That's important. In the LEED O&M world, we're going to have site maintenance strategies, right? Remember, LEED covers the life cycle of the building, its design, its construction, and maintenance. So LEED, EBOM, existing building operation and maintenance. We'll talk about maintenance of the building. So some maintenance related things that would fall into LEED O&M Sustainable Sites would be a management plan related to herbicide and pesticide use and building cleaning, you know, maintaining those undeveloped site areas, protect or potentially restore, right? If we have a large parcel of land and we've only built on part of that parcel, we have to make sure that we as the owner, or we as the construction professionals representing the owner, make sure that undeveloped or set aside site areas remain undeveloped and set aside. We have to maintain and control our site lighting, right? Make sure that our dark sky compliant fixtures continue to perform as we expect them to over the life of the building. We talked last week about some of the stormwater mitigation strategies. So again, from a design standpoint, we're going to reduce inflow, increase infiltration, and detain or retain, right? Keep that stormwater on site. And we looked at things last week, rain barrels, rain gardens, bioswales, detention and retention basins, right? These are all things that should be included as part of the design of the building. Again, just a reminder, I have things mixed and matched in my lectures here, right? Why are we concerned about stormwater, right? Where we obviously, we talked about a couple of weeks ago about water quality impairments, you know, that rainwater falling on an impervious surface, all the stuff, right? We just had a heavy rainfall last night and today, so all the junk that was on the street, you know, all the dirt, all the spilled gasoline and motor oil, and everything else that was on the street, all that got washed into the storm sewer or into the combined sewer system, and you know, has ended up either in a water treatment plant, or I'm sure we had some kind of combined sewer overflows yesterday, right? So I'm sure there was some stormwater that got discharged into a river, right? So again, all that motor oil and auto fluids and road salts and pesticides and dog poop and everything else, right? That all ended up in the Des Plaines River, and that is called a non-point source of pollution. Non-point sources, right? The pollution from discharge from a factory smokestack or something like that, that's a point source of pollution. Over the last 20 or 30 years, we've gotten relatively good at controlling point sources of pollution. These non-point sources are much more of a challenge. We have a number of development strategies, and again, I have links at the bottom of some of these slides too, if you want more information. But low impact development or green infrastructure, right? This is a development strategy where we're trying to mimic the natural processes in terms of infiltration, stormwater management. So again, this is another name for some of the things that we talked about. You may run across the term low impact development. Again, so some of the design strategies, we talked about these last week, and my green lights keeps blinking on and off. It's driving me nuts here. Minimize impervious surfaces, increase infiltration, porous paving materials, you know, detain that rainwater with a rain garden or a bioswale or a green roof, retain or store that water in a cistern or a wet stormwater basin or retention pond. From a maintenance standpoint, make sure all those things, again, over the life of the building, the designer has to design something that has to get built and then it falls upon the responsibility of someone in property management or facilities management to make sure that that rain garden or that feature is maintained over the life of the building. Right, so someone at Triton has a responsibility to make sure that those native plants have some maintenance, that all those systems continue to work. One thing that the LEED Sustainable Sites Credit category is attempting to mitigate is what's called the heat island effect or urban heat island effect. Right, we probably know this on some level, even though we may not know the right name or technical terminology for it, but in an urban area, temperatures tend to be hotter than they are in surrounding rural areas, right? In an urban area, we have lots of buildings, we have dark roofs. Those roofs are absorbing heat. We have parking lots, we have roads. All those things tend to increase the temperature in an urban area as compared to the surrounding rural areas. So again, what strategies does the LEED credit category system imply for this, right? We have some things that we can do to minimize the heat island impact, some design strategies. We can use reflective roof materials, a white roof, high SRI, solar reflectivity index, right? That has to do with the material's ability to reflect that heat. So a light colored roof rather than a dark colored roof. You know, we can reduce hardscape. We can use lighter colored, shouldn't say lightning colored, just say lighter colored paving materials. We can shade, right? We can have shade trees covering the street. We can have a green roof, right? All things, all strategies that the designer can employ to reduce this urban heat island effect, right? What makes the H building LEED certified? Again, we didn't see it from the ground when we walked around a couple weeks ago, but from the architecture studio, you can look out across, look north, and look at the roof of the H building. You see that it is a white roof, so it absorbs less heat from the sun, reduces air conditioning costs, at least reduces the contribution to the urban heat island effect from this particular building. And we talked about green roofs being another design strategy that would reduce the urban heat island effect. Again, this is a extensive green roof system, a thin soil layer. Again, the idea here would be that we're going to help mitigate that sun beating down on a dark black roof, right? We're going to have multiple benefits from this green roof: reduce air conditioning costs, reduce urban heat island effect, you know, detain stormwater. Again, like many things, we have a design and construction. We also have maintenance. So in the LEED EBOM or O&M credit category, we'll have some credits tied to maintenance, right? We got to keep that white roof clean. Maybe not as much of a problem here where we just got a bunch of rainfall, but that characteristics of the roof need to be maintained. Obviously, the landscaping and the trees and the green roof, those things all need to be maintained over the life of the property if we're going to continue to reap the benefits. The world's whitest paint. No, I have not, Bea. Maybe I'm assuming it would be is this a white paint for this particular white roof application, Bea? Do you know? I mean, I assume white mean highly reflective.
Well, I don't know if they developed it for the roof specifically, but I like read the article a couple weeks back, and I was just kind of like thinking about that when you were talking about white roofs. So I think
I
it's
have
just a
not.
general. Yeah, I can link the article if you're interested.
Do me a favor if you think about it. I'm always, I'm a geek for learning new things, right? So if you think about it sometime, Bea, just send me a link to the article or send me the article.
All right.
Great. So again, here's our lead BD&C scorecard, new construction. We see the sustainable sites credit category. Right, we have some things that are required: construction activity, pollution prevention, right? So that would be something that's required. That's, I think, generally going to mean, protecting trees and vegetation, having a silt fence or some strategies to, prevent the soil from running off of our site during construction. And then some of the things you see there: site development, protect or restore habitat, open space, rainwater management, heat island reduction, light pollution reduction, right? We just talked about all those things. Right, so again, in BD&C, these credits are focusing on design, and in the O&M world, they're going to focus on operations. Right, again, and we saw this in LT a couple weeks ago, right? The buildings already exists. We don't have much that we can do from a credit standpoint in terms of location. We have some things we can do on transportation, but again, in O&M for sustainable sites, we have a site management policy which would be required: protect or restore habitat, rainwater management, heat island reduction, light pollution reduction, et cetera, right? So again, maintaining or hopefully improving the performance of the building over time. Right, again, here's our prerequisite for sustainable sites in BD&C: construction activity, pollution prevention, reduce pollution from construction activities by controlling soil erosion, waterway sedimentation, airborne dust, right? Right, this was, I think I just put this in there to site assessment, maybe something you're not familiar with, right? What is the site assessment? Right, this would be part of the design process. Evaluate sustainable site options and inform related decisions about site design. Okay, any questions? Those are lead strategies for the SS, or sustainable sites category. Okay, I'm just watching the clock here and seeing my little green light blink on and off. So let's jump over to the next one here. We'll get a running start on this before the break. So again, we just talked about the lead SS, or sustainable sites credit category. We will now look at some strategies for the WE, or water efficiency credit category. I remember before we, a couple weeks ago, we looked at the infrastructure that supports most of our buildings, a supply infrastructure and a wastewater treatment and disposal infrastructure. Again, the term you might hear in this context would be POTW, or publicly owned treatment works, right? So in the case of where we are, the agency that does the POTW around here is the Metropolitan Water Reclamation District, MWRD. So like me, if I'm driving to Midway Airport or taking the taxi to Midway Airport, I'll drive by the big water treatment plant in Stickney. Right? That's an example. That's wastewater treatment. Again, in our case, where we are located, our water is likely coming from Jardine Water Treatment Plant. Again, that's that big structure that juts out into the lake just north of Navy Pier. So that's where our water comes from, and that's where our water gets treated. Okay, so in the water efficiency, we're going to look at both in the LEED rating system, look at both indoor and outdoor water use. In the indoor water use, LEED generally is working with, generally working with plumbing fixtures. So in plumbing fixtures, we will typically have some kind of rating for GPF, gallons per flush. Right, so a toilet or a urinal will typically have a rating in GPF, or gallons per flush. A faucet or an aerator, in a lavatory sink or a kitchen sink, will typically have a rating in GPM, or gallons per minute. And in the LEED rating system, we're trying to improve upon, what are already the fixture requirements. This is actually quite some time ago, EPACT of 1992, right? A federal government law passed many years ago now that talked about ratings for different plumbing fixtures. So again, LEED is going to say, okay, I'm not going to give you credit for doing the minimum. I'm going to give you credit for doing better than what EPACT were. Right, again, WC's water closets used to typically be 3.5 gallons per flush. Nowadays, we're starting with 1.6 gallons a flush and trying to improve upon that. Right, so again, in LEED WE, credit category water efficiency, our prerequisite is to do 20% better than the baseline, right? The baseline means if you take all these EPACT requirements, you got to do 20% of that, 20% better than that as a prerequisite, right? Just to get in the game. Some other definitions here, right? Some different terms. Obviously, potable water is drinking water or white water. I don't know. This one, white water, confuses me a little bit. I think of white water as something that you do, in a raft or a kayak. Well, I don't do it anymore because I'm too old for that kind of stuff. Some of you might find that thrilling and adventurous, but potable water is what we drink. Non-potable water is water that's not drinking water quality, but still can be used for other purposes, right? We can use, again, in the case of Triton, we're collecting rainwater, storing rainwater off of the parking lots in a cistern. That's non-potable water. We're not trying to drink that water, but we're using it for irrigation, right? We're using it to water the lawns, right? Not drinking water quality, but still can be used for other purposes. Gray water is used water that comes from sinks, showers, tubs, washing machines, things like that. So we'll see that in some cases, we can design systems to reuse that gray water for other purposes. Black water, right? That's the waste from toilets and urinals, right? Black waters come in contact with fecal matter, right? So that's bad. We can't reuse black water. So generally, we have to separate. Gray water is something we might have the opportunity to reuse or do something else with. Black water we can't, because that's a health matter. Right, so what are some of the strategies that we can employ for reducing our indoor water use? Right, we want to pick the most water efficient plumbing fixtures that we can. We may have places that we can use non-potable water for certain uses, right? For toilet or urinal flushing, it would be a potential use for gray water or non-potable water, right? Gray water or rainwater. Obviously, we also want to track what we do, sub-metering. Again, this would get into the LEED EB O&M world, right? Tracking and monitoring to make sure that the design strategy, what was built into the building is still being utilized. Again, some examples of water efficient plumbing fixtures, right? I'm guessing that many of you are familiar with this already, these sorts of technologies, right? Low flow toilets, 1.28 would be a typical low flow toilet specification, or dual flush toilets, right? We can have a lower flush rate for liquid waste versus solid waste. Again, these are strategies that the designer or construction team might employ. In the case of urinals, we have low flow or ultra low flow or waterless urinals. Again, these are all possible design strategies. That waterless urinal has additional maintenance requirements that might add some costs and might not make it worth doing that. But again, there are some strategies for water efficient plumbing fixtures, for water efficient urinals. Over in the good question. I would say generally not. First of all, Ayana, in most residences, we don't. I mean, a urinal is typically a commercial plumbing fixture, right? In most homes, right? Most homes have a water closet or a toilet, right? It's extremely rare that you would have a urinal in a residential setting. So I would say that I'm looking for a picture of a water closet, right? I would say, generally speaking, that's going to apply to a commercial. In a residential setting, I thought I might have a picture. I think this little dual flush picture, I think I may have taken this from taken a picture of the little the flush that I have in the toilet in my basement, right? We have two We have an upstairs and a downstairs. In our downstairs, newer downstairs bathroom, we have one of these Toto toilets that has dual flush, right? You push one side for, for liquid waste, the other side for solid waste. So yeah, I don't, pretty sure you're not going to find that in a residence. This is generally speaking commercial stuff. In the LEED EB or O&M world, right, we're in an existing building. We may want to look at doing a retrofit of the existing plumbing fixtures to reduce their water consumption. In the case of an existing commercial building, we have to consider, whether the fixture itself, whether the china has been designed for low flow, right? China refers to that water closet or that urinal, right? For all this stuff to work correctly, the china, the fixture itself, and the flush valve, have to kind of work together. I think certainly in my experience and other people in the retrofit world, right, we tried to go and do water conservation retrofits on older 3.5 gallon per flush china, and we didn't get good results, right? We tried to take that 3.5 GPF china and flush it at 1.6, and it didn't work very well, right? Got a lot of complaints. So, we've learned that if you want to do a successful, retrofit water conservation program, you got to do both things. In commercial buildings, we often have processed water use, right? We just looked at, water use for toilet flushing. We obviously have drinking fountains. Well, we used to have drinking fountains. I don't know if we're going to continue to have drinking fountains now post-COVID, but in commercial sites, we also have processed water use. Right, we might have makeup water for a cooling tower, right, as part of the air conditioning system. We might have makeup water for the steam boiler. We have water involved in food service or laundry. LEED is not looking as hard at these uses of water. It doesn't mean we as thoughtful designers should be looking at these things, but LEED may not necessarily point us in this direction. Again, right, what is a cooling tower? Right, so on a roof of a building, you might have a box like this. That's a cooling tower, right? That's where the heat that the air conditioning system takes out of the building gets rejected to atmosphere, right? So in this case, we have makeup water that goes into that cooling tower system to make up for the water that gets evaporated, right? So this is a processed water use. Let's do this. It's about 5 minutes to the hour. Let's take a break here because I'm looking at the number of slides here, and I'm about halfway through the presentation, so I'm not going to get it all done. Let's do this. Let's take about a 10-minute break. And during that break, if you have not looked at that article, please take a look at that. And when we come back, we'll mix things up a little bit. I'll break you up into groups, and we'll spend 10 or 15 minutes talking about the article. Let me stick it up on the screen here. Hold on a second. Right. if you're not stopped by the paywall, this would be what you would see in the New York Times article. If, like I think Max said, you bash your nose into the paywall, then you can look at the PDF. But this was kind of interesting. I'm always on the lookout for things that are kind of cool and interesting. So that's why I picked this one. So over the break, if you haven't already, take a break and take a look at this quickly, and then when we come back at I don't know, 8 or 9 minutes after the hour, I'll break you up into groups and give you a chance to discuss this a little bit. So we'll see you back in 10 minutes or so.